Previously we looked at integrating functions that were standard integrals, but this isn't always the case, and in these situations we can use a method called substitution. Now, different substitution methods are available, and one of the most common is called algebraic substitution. And in this situation we let the original function equals u, where u is a standard integral. We then integrate with respect to u, and finally, once integrated, we return the integral back to an original function of x. So let's have a look at a question using substitution. In this question, we're asked to integrate the following function. Now, as we can see, this isn't a standard integral. And if we let u equal to 4x squared minus 2, we could differentiate u with respect to x to give 8x. And if we cross multiply, we get du is equal to 8 times x dx. Now, in the original integral, we could take out 8x dx and replace it by du. And substitute u for 4x squared minus 2, the integral now becomes u to the power of 4 times du. And if we integrate u to the power of 4, we add 1 to the power and divide by the new power, which gives u to the power of 5 over 5 plus a constant. And u is 4x squared minus 2, so re-substituting that back in, we get 4x squared minus 2 to the power of 5 over 5 plus a constant. So here's a question that you could try. Integrate the following function with respect to x. So first decide on a suitable substitution and then go ahead and integrate. So we could rewrite the integral by taking 3 outside to give the following. And if we let u equals x to the power of 5 minus 2, du dx becomes 5 times x to the power of 4. Cross multiplying gives du is equal to 5x to the power of 4 times dx. And if we divide both sides by 5, we get 1 over 5 du is equal to x to the power of 4 times dx. So substituting u for x to the power of 5 minus 2 and replacing x to the power of 4 times dx with 1 over 5 times du, we get the following. And integrating u squared, we get u to the power of 3 over 3. And if we re-substitute x to the power of 5 minus 2 for u, we get the following expression. And as you can see, the 3's cancel and we're left with x to the power of 5 minus 2 cubed over 5 plus c. So let's have a look now at integrating a trigonometric function. Here we have a function 2 times cos 4x plus 2, and we can use substitution to integrate this function. So here we could let u equal to 4x plus 2, and if we differentiate u with respect to x, we get du dx is equal to 4. And if we cross multiply, we could write dx is equal to du divided by 4. So substituting u for 4x plus 2 and du over 4 for dx gives us the following. 2 into 4 goes twice, and take the half outside the integral sign, we get the following. And if we integrate cos of u, we get sine of u. So re-substituting 4x plus 2 for u gives us a final answer of a half times sine 4x plus 2 plus a constant. So here's a problem that you could try. And finally, we'll do one more question where we're asked to integrate 1 over x plus 2 to the power of 4. Now have a go at the question first yourself and then have a look at the video for the solution. So here we let u equals x plus 2. So differentiating both sides, we get du equals dx. So we can now substitute u for x plus 2 and du for dx. So we now integrate 1 over u to the power of 4. Now 1 over u to the power of 4 is the same as u to the power of minus 4. And when we integrate, we add 1 to the power and divide by the new power. So this becomes minus 1 over 3 u to the power of minus 3 plus c. So we re-substitute x plus 2 back into the equation for u. So we get minus 1 over 3 x plus 2 to the power of minus 3 plus c.